All right, Algebra 1, we're back and we're going to be still dealing with polynomials. This one we're going to be learning about multiplying binomials. That's the fancy name of it. But the strategy we're going to use is called FOIL, F-O-I-L. Okay. And I have up here what FOIL stands for. First, outer, inner, last. Okay, so just keep that in mind. It doesn't make any sense right now. But basically, what we use that for is when we multiply a group of terms times another group of terms. Okay, because before we learned kind of how to do like a single term times like a group of terms, right? And we learned that we, just like normal, we distribute that or multiply that term on the outside times every term on the inside of that group, right? But when we have a group times a group, okay, it's going to be a little bit different. We have a little bit more multiplication to worry about, okay? And another name that I like to use for this is called double distribution, okay? Because like from this first group, I have to multiply each of these terms in the first group by each of the terms in the second group, okay? So how that's going to look, right? If I have this A term, I have to distribute that A term to both of these, right? So kind of in general, that would be A times C and then A times D, right? That A is distributed, but also, right, this B needs to be distributed. Okay, so it would be B times C and B times D as well. Now, where this FOIL comes in, first, outer, inner, last, that's kind of telling you the order that you would do all these multiplications in, right? Because there's going to be 4 multiplications that happen for when you have a group of 2 times a group of 2. For a group of 3 or bigger one like number 4 here, it's going to be a little bit more multiplications, but 4 multiplications, okay? So that basically is telling you the order. So first would be the first term in this group times the first term in that group. So A times C. So the first terms. The outer two terms are the next one, right? A times D. So the outer two terms. The A is the outer, and then the D is the outer, right? So the two terms on the outside. Okay. So first, and then outer, and then third is inner, right? So it's the inner two terms, kind of the opposite. So it'd be B times C. So these middle two terms are the inner. And then the last two terms, right? So it'd be B times D. So that FOIL can help you to remember just that there's 4 multiplications and that's kind of the order that you do it in. Okay. So that's kind of the general rule to keep in mind. Okay. Now, if we look at ones with actual kind of numbers and terms inside, that'll help us to kind of see what more of these examples will look like. So for this number 1, right, same thing. Let's follow this. So first, I multiply my first two terms in the groups. So x times x. And I could even kind of combine that and simplify it kind of as I multiply. So x times x would be x squared, right, when I multiply x times x. So that was first. Outer would be the first x times the 7, right? The outer two terms multiplied. So x times 7, right? So x times 7, right? When it's a number times a letter, right? I could just kind of lump those two together. So it'd be x plus 7 or 7x, right? And then the inner two terms, right, would be the negative 3 times the x. And again, you do think of this as a negative 3, even though this is kind of, you think of this as a minus sign, you think, okay, this is negative 3 times x, so that would be negative 3. And then my last two terms, okay, last here would be the negative 3 times the positive 7. So negative 3 times 7 would be negative 21, right? Those are two numbers, so I can multiply those like normal, okay? And then you look at this group, okay, and oftentimes this is going to happen, okay? Specifically, these two middle terms, if you guys remember from when we talked about adding and subtracting, right, we said you can add and subtract two terms that have the same variable and the same exponent, right? So notice I didn't underline this x squared because it has a 2 exponent, and these two would just have a 1 exponent. Even though it's not written, that's kind of the standard exponent. So, but these two are the same, right? They both have an x and they both have the 1 exponent, so I can combine them, okay? So when I combine positive 7x minus 3x, I would think 7 minus 3 is positive 4x, right? Combining those two like terms. And then the two terms on the outside don't have any like terms, so those would just come down and stay the same that they are, and negative 21. So this would be kind of my answer. If I'm just like foiling this, I like to say foiling because that's kind of how I multiply these. But yeah, if I did FOIL these, I would get this group as an answer, okay? Again, most of the time, you are going to end up with just 3 terms as an answer. Even though there's 4 multiplications, again, we're going to be able to often combine these 2 middle ones, okay? So that's number 1. Let's go over a couple more like that, and then we'll have a bigger one at the end, okay? So this number 2, again, the same order. So first, so 2x times 1x. So 2x times 1x, again, you could think 2 times 1 is 2, and then x times x, x squared, right? So 2x squared, right? So first, outer, right? My 2 outer terms. So that would be 2x times positive 9. So I could do 2 times 9 is positive 18, but then the x comes down, right? So 18x. So first, outer, inner, right? The inner 2 terms. So 1 times 1x. So 1 times 1 is 1, and then the x comes down like that. And then, so first, outer, inner, last, right? My last 2 terms here. So 1 times 9 is just positive 9, right? So you did all your multiplication, but again, now we want to look and see, okay, any like terms in here that I can combine? And again, like I said, almost every time it's going to be the 2 middle terms, right, that I can combine. So I would, again, a 2x squared comes down. I would do 18x plus 1x to get 19x, and then that plus 9 comes down. Now this number 3, look at this one. Okay, a little bit more complicated because the second terms are not just constants, but they're y terms now. Okay, so it's the same process of FOIL, but the multiplication is just going to be a little bit more complex. Okay, so it'd be 3, same order. So first, 3x times 5x. So again, 3 times 5 is 15. X times x, x squared, right? So that's first outer. So 3x, so think about this, 3x times negative 1y, right? So 3 times negative 1 is negative 3. But then my variables would be x times y. And those aren't the same type of variable, right? So here's what you would do for that. You would just kind of lump it all together. You can't combine x times y to get like some single thing. So you would just kind of lump it together, 3xy, okay? And then inner, okay, same idea. Negative 4 times 5 would be negative 20. And that's the same thing, right? Y times x, right? So I can't multiply those. So I could put 20yx, but again, we usually, with a situation like this, we go alphabetical order. So we would go negative 20xy. And again, we're allowed to do that because multiplication has this rule that says you can multiply it in whatever order, and it's the same thing. That's called the commutative property. You might have heard of that. But so negative 20xy would be the inner 2 terms, right? And then my last 2 terms, so negative 4 times negative 1. Remember this rule, negative 4 times negative 1, positive 4, right? And then y times y, right? Those are the same variables, so I can actually multiply to get y squared, right? So a little, you see, it's the same process, but just a little bit more complex with those y's there. But then again, our last step is still the same too, with checking our 2 middle terms, right? And again, doing our check. Do they have the same exponents and the same variable? And, right, they both have x and y as their variables. And again, I don't have them written, but those would all be 1 exponents. So yes, they would be like terms, exactly, because they have the same variable, same exponents. Okay, so that means I can do negative 3 minus 20 to get negative 23xy, right? So just combining those. And then again, bringing down the other terms. Even though these have the same exponent, they don't have the same variable. So those are close, but they're not like terms. So I can't combine 15 plus 4. Okay, so I would leave them separate. So 15x squared minus 23xy plus 4y squared. And now my last one here for number 4, okay? So I have x minus 5, that group of 2, times a group of 3 terms, x squared plus 3x minus 10. Okay. Now I can't think like you can think about the process of FOIL, but you can't use that acronym necessarily because right, there's more terms to distribute to. So basically what you think there is that again, it's the rule of like double distribution where it's like, okay, this x is going to be distributed to every term in that group. Okay? So that's actually 3 multiplications. The x times the x squared, the x times the 3x, x times negative 10. Okay? And then the negative 5 is also going to be distributed to all 3 of those. Okay? So it's every term in the first group multiplied by every term in the second group. Okay? So I'll do the negative 5 after, but let's just do the x for now. Okay? So it'd be x times x squared. So x to the first times x squared would be x to the third, right? And there's no coefficients on those, so we can just leave that off. And so now x to the first times 3x, right? So my second multiplication here, x times 3x would be positive 3x squared, right? And then x times the negative 10, so x times negative 10, again, number and a letter, so we just lump them together, negative 10x, okay? So I distributed my first term times all the terms in that group, okay? Now I need to distribute this negative 5 to all the terms in the group, okay? So you see that there's 6 multiplications that happen when we have a group of 2 times a group of 3, okay? And so now, now I would do negative 5 times x squared. Again, number times letter, so I lump them together, negative 5x squared, okay? And then I would do negative 5 times 3x. So negative 5 times 3, negative 15. And then there's just the x on that one, so we just put that on the end. And then I would do negative 5 times negative 10. Negative 5 times negative 10, positive 50. So lots of multiplications there, right? We did 6 of them that time because there was more terms in that second group. Okay, but again, now we look at these, and again, usually with a group of 2 times 2, right? Binomials means 2 terms. Okay, so group of 2 times group of 2. Our middle 2 terms are the ones that can combine. Okay, but with this more complicated list, it's going to be a little bit harder for me to locate those because they're not going to be like right next to each other. Okay, but remember your rule for this. It's same variable, same exponent, we can combine. Okay. So this x to the third, right? Obviously, all the variables in here are x's, so it's going to meet that rule. But what I want to look for, do any other terms have that 3 exponent? And no, right? None of those have a 3 exponent. So that means this x to the third does not have anything to combine with, okay? So that just comes down. Now I look at this 3x squared, okay? Any other x squareds, right? X with a 2 exponent. And I have that, right? I have one right there. So it would be positive 3x squared minus 5x squared. So 3x squared minus 5x squared would give me negative 2x squareds, right? The exponent doesn't change, just the coefficient out in front, the big number. And then I look at this term, right? And this is, I said this when we were doing the adding and subtracting polynomials too. Once you bring a term down kind of in your final answer, you can kind of cross it out because you dealt with it already. Okay, you kind of combined it and now you have less terms to look at. All right. Now I have this negative 10x, okay, and the other x terms in there, right? This negative 15 has it, right? So I'll do negative 10 minus 15. So negative 10 minus 15, negative 25x, right? Negative 10 minus 15. So I use those. And then this plus 50, right? That's my only term left. And there's no other constants in there. So I just bring that down as a plus 50. So that would be that whole group, okay? And I always get the question too, oh, what if you had like 4 terms times 4 terms or like huge groups, right? And yes, just that rule is every term in the first group needs to be multiplied by every term in the second group. So if you had like 3 terms times 3 terms, there would be 9 multiplications. If there was 4 terms times 4 terms, there would be 16 multiplications, okay? So that can kind of be a clue too into like how many multiplications there is. You would just multiply how many terms are there in the first group times how many terms are there in the second group. That tells you how many multiplications there should be, okay? But that's the basics, okay? Yeah, so thanks for following. Good job.